on this Super Saiyan project, and effectively, yeah, how you would start is this: the Hello STK. Right? So you would install this or download this as an open source project, have it working on your machine, and how it looks like, because all of these projects, since they're Javacard, have to be simple and don't have to take up space. We can look at all of them, or at the code base for all of them. Right? So let's say hello STK, so on and so forth, library source, hello STK2. So this is basically your Hello World version for an SDK applet. The first thing you need to know, Javacard is like Java and C++, or Java and C having a baby. Huh? So you do not have ints, you do not have chars, you do not have strings. You have bytes, shorts, and I think that's about it. Right? Some versions of JavaCard have big number, like so that you can have an integer, but most versions of JavaCard don't. So what you do if you want to program a JavaCard program that works on everything is you use bytes. As you see, this is the string for the welcome message, and it says welcome to Tory Camp 2012. Right, this was a 2012 version. Oh, and I have my notifications on, so if you'd like to see my messages for the next 40 minutes as they come in, enjoy the show, or do not disturb. Thank you, God. Oh, imagine what could have been coming in. Cool. And yeah, so menu message, hello SDK as well. So these are all the things you'd have to do, and when you install it on a SIM card, when you run this program on a SIM card, the SIM card will run the constructor once. Right, I hope that makes sense. And then on the constructor, it registers the menu and gives it a name and all this good stuff. And it also runs an install method once. And process is the APDU. It processes the APDU. So during my talk, I talked about something where you can pass it hex code. So this is what processes that hex code I showed on screen that I said once it gets that, it sends an SMS. Right? But that APDU to send an SMS is in this phone, is not on the Java card, right? So this is the APDU that the Java card gets sent. So the phone can also send APDUs to the Java card, right? So this is where you put logic to receive commands, and well, you can send commands from anywhere you want. APDUs, application protocol data units. That's what it's called. So if you want to communicate with a Java card chip without a user interface, this is where you would put all of that magic right there. And as you can see, this is empty. The reason why this is empty, this is a Seam Toolkit applet, and the Seam Toolkit applet only does this. Right. It only says, oh, this is similar to process, but it says process toolkit. So when a person opens the toolkit applet, it runs this code, and it wants to see if the event is a menu selection. Then we get the event handler, and then we say show hello, and then we show hello by displaying text. Right. Cool. That is the first thing you'll have to run. Right. So the other thing you need to know when you're running this is that you cannot use the latest version of Java. You use Java 8. So, of course, I'll be running stuff. So let me open a terminal real quick. Cool. Sudo documents dev Javacard hello SDK. But I shouldn't be using this anyway. And history grep Java home. So every time I have to do this, I set my Java version to an older version, so which is bad, right? Because ultimately it means that everything else I do with this laptop, if I'm a Java developer or if I develop Java related apps, I cannot do it because most of the time I'll be doing this, right? So, this hello STK one has a makefile. I don't want that. So here's what I'll do. I'll go to the Spectre Javacard project and I say ent, and then Spectre Javacard runs, so on and so forth, blah 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 blah. As you can see, magic, wonderful, build successful, right? So maybe let me open a new tab and see what the Java home version for this is. It's 18, right? Let's see what happens when I build in here. Build failed, right? Source target option 6 is no longer supported. Use 7 or later, right? So every Javacard project you will find in this folder, right? All of them, like everyone here, will not work on your latest Java version. You do not want to know how much time I spent on that point alone, right? So to understand what I did is I ended up buying an old laptop, but it's not really old because it was running Windows 10, and I installed Windows XP on it, and then I installed Java 7 on it, right? Just so I was like, okay, I need an environment where this old stuff used to work, right? So, and I didn't want to figure out how to make it work on my new environment. And only later did I learn that all I had to do was effectively just run this line of code, right? Export Java home, Java 8, and that's it. So then I can use this on any machine. Cool. And yeah, so effectively, once you're done with your Hello STK, you would want to look at the other projects that are doing this stuff, right? But which projects are the most useful? For me is the Spectre Javacard, right? So Spectre Javacard, mad respect to those guys, right? They are really doing, oh, wait. But before them, I have to shout out this library as well. This is the JC Math library. So if you go to GitHub, JC Math lib, you can find this. It's an open crypto project. This is what I was talking about when I was saying should this be open source or closed source. So with the Javacard math library, before this library existed, for you to do cool crypto stuff, you would have to get a chip that supports cool crypto stuff, right? But these guys says no. Most of these things you can implement in Javacard if you dedicate enough time. So we are just going to implement them for people and make them available as libraries, right? And yeah, it's these guys and a few others that are doing this wonderful work of making things available as libraries so that you do not have to worry too much about how you would calculate a checksum or stuff like that. Right? And yeah, that being said, there's still a lot of stuff missing here. Let me see, what do they have? Open Crypto, JC Math, Big Net internal. Okay, so Big Net is a big natural number. As I was saying, the latest Javacard chips have a big number, right? But if you're not using the latest Javacard chips, you just use this library and use BigNet, EC curve, EC point, example, all of this cool stuff basically. And yeah, and all of this code 90% of the time looks this simple. It's like 100 lines of code all the time when they give you sample applets. So yeah. Then where do we go from here? Oh, I was mentioning Spectre Javacard. Because I believe these guys really did a very good job with their project, right? And so this is why they did a great job. So again, GitHub, you just go to their repo and you go through their contents, and effectively they did this project in 3 parts. Teapot just stores tea, and then you can pour out the tea that you poured. So the tea in this case is data, and they say they can store up to 25 bytes, right? And then they did a secure element with a pin protection for secure communication, cool. And then a memory card, extend secure applet, allows arbitrary data storage. So it commands security with the teapot functionality, and then gives you a memory card, a secure memory card. And then a blind oracle, which is a secure element, stores a root private key, right? And then does BIP32 key derivation, right? So, or single use, where it just stores a temporary private key and doesn't do BIP32 root generation. So BIP32, if you don't know what it is the reason why every wallet can support millions of keys without having to back up the keys. It's called hierarchically deterministic keys. I once had a project, and I'll love to shout out this project. Hopefully the project is still alive. Off 32. No, it's not. Off. Oh, is it off just? Off.com. Should be live. Yeah, cool. Hierarchically deterministic authentication using digital signatures, and yeah, there is presentation on this where I basically use BIP32 to do like an authentication system. Right? It was a simple system. Basically, background, all you need to know to use it is cryptography. This is the paper, I think, that explains how BIP32 works. Let me see. Okay, but let it load. And then definition, cryptography is information binding. Blah, blah, blah. This is really not important. So yeah, but you'll check it out. If you check out the paper, you basically get all the information. Of course, you need to get it from an archive. Oh yeah, and in doing this work, what you need to always do is use the Wayback Machine, right? Because you're gonna find something, a link to something that's not there anymore. Like let's say this Hello STK had a link to this thing. I think this one is still there because it's the second version of this, right? So oh, 404, right? So Wayback Machine, you take the same link and then say blah blah blah, open up, and then you try to find a version of this that was still live before they took it down so that you can get this information. This is a very important step in the whole workshop. If you skip this step, you won't be able to do any of the other stuff that I'm about to mention. And yeah, okay, the link is not on Wayback Machine. I'm sorry, so I won't be showing that. So yeah, Spectre Javacard, that, and now to the good stuff. Now to my own code base, which is Freezer, and I've covered everything. Though. Oh, before I go there though, let me look at the specifications. Right? So for you to know what you should be able to do with Javacard, you need to read the specs, right? And you get the specs from ETSI, ITSI. Yes, you get the specs from ITSI. So etsi.org. Oh, this is their website. Cool. And you search for whatever you are searching for. Right? And here's the search button. Search menu. Come on, come on, come on. Oh my goodness. Internet, why are you letting me down? Okay. Oh, let me just say standards. You search for the standard, and let's say USSD. If you ever really want to understand USSD, this is the place to go. And here it is, unstructured supplementary data, and you get the thing. Smart cards. What am I doing with Javacard? Javacard? Do they have something with Javacard? Smart cards, test specification, UACC, Javacard, blah 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 blah. So you need to know the specification that you are using. Oh, okay, so this is then part 2 of the workshop, right? So I have, oh, this is all the non-code stuff that I do. ITSI is over here, right? So these are the 2 most important projects you'll ever need. 14309, right? So you search for 1430019, cool, and then you get that paper or that specification. As we all see, it has multiple versions. There's version 6, which got withdrawn, and version 5, which is ranked higher. I don't know how they rank them, from 2003. and then version 4 from 2002, and a few others that got withdrawn in 2005, 2002, so on and so forth. And then there's others that are related, like 00034. I don't really know what 34 is about, but I think it mentions the one I was searching for. So, or intellectual property rights, probably. It mentions the one that I was searching for. So they brought it in with the results. So what you would usually do is then get the PDF. Oh yeah, but this is what you look out for, this zip file. Right? But the PDF is also good. The PDF is what you read, so on and so forth, so that you are clued up with how the things are supposed to work from a specifications perspective. But the zip file is where the magic is for me, because I hate reading. I'm like a person who loves pictures in books. So what I do is just go to the folder that I'm looking at. What was the software? Etsy. And then, okay, let me open here because I'm gonna be looking at the other things. So these contents are from the zip file that is offered on the standards platform, and as we see, they give you HTML files, which is like the docs, right? And then they give you sample projects, Java sample projects, and then they give you export files, right? Export files in Javacard are very important because there's no build environment. So if you are going to use 102.267, you are going to copy cap and the export file and paste them in your project, because most of this stuff is not on GitHub anyway, and tell your build tool to look for them, so that you have the logic for these classes: connection close, connection constants, blah blah blah. I don't know why you still need the export file when you have the source code. Oh, because you don't have the source code. These niggas are tricky, and they have weird things all over the place, right? And so what you do is, yeah, look at the sample projects like Java here. Oh yeah, the toolkit applet example. This project, I loved it so much. This was my favorite one of all, because it allowed me to see how SMSs got sent, and how there's something called a bearer independent protocol. Oh yeah, this is my conspiracy theory. Bearer independent protocol. Right? I believe when the point of sale device, when you tap your card to pay, it uses this protocol to communicate with the payment, with Visa or MasterCard, and then the process succeeds, right? You cannot get a sample server for this anywhere on the internet, right? Believe it's probably because of NDAs, so whoever deploys it signs an NDA to not release it, right? But at some point we're gonna do version of this for Bitcoin, right? So that we don't have to do SMSs anymore. We could just use bearer independent protocol. And yeah, this is also an applet that shows you how to do a bearer independent applet protocol call. Yeah. So what is missing is the server side logic. This is client-side logic. What am I going to do when I have the APN? Then you need what other stuff like the IP address you're calling, and things like that. Oh yeah, GSM8. I think this is some of the stuff. So, but anyway, back to the original plan programming. Same thing, constructor. Right. This runs once on the Java card when it's installed on the Java card or on the SIM card, and then it also calls install at some point in its lifespan, and it does weird stuff, and it processes toolkit. It doesn't do process. Oh yeah, it also has process. So process then gets the buffer and sees an instruction, and then it does some good stuff, right? And cool, the process toolkit then says we start up. If this is an event menu selection, what we do is select, and then this is what we show, the menu title, and these are the items we show. This code is very unreadable, and this is why this thing has taken me so long. And oh yeah, but the Spectre guys are quite good at this, as I mentioned earlier. Let me open their stuff. So Spectre, I'm just gonna open Teapot, and Teapot is over here. Teapot supports these instructions and these commands, get, put, and oh yeah, actually get and put, because it's a teapot. So your teapot pours tea and then it puts tea in it. That's all it does. This is the install. It's ran once. This is the constructor. It's ran once as well, and process the APDU. It does not have a process toolkit because this is not a toolkit applet, a sim toolkit applet, right? So how you know something is a toolkit applet? It implements the toolkit interface. Right? And so I could search GitHub now and to go back to that thing I once said, code results. Cool. Yeah, toolkit, and basically these are all the projects that implement the toolkit interface. Oh, now there's 75, so there's been 5 more sim toolkit projects ever since I started working on this, and yeah, there's the 75 there. So which means later today or later this week I might go figure out which ones are the new ones, and then see how these guys did it. And yeah, cool. But then back to Spectre, Javacard, and with their teapot thing. So their code is very well organized, right? This is the default data that they put in the tea. I am a teapot. Give me some tea, please. And then when you put information in it, it overrides the previous information you had in it. It processes the APDU. This is the default APDU, like select the applet, so it just returns, and then you can get the buffer and then set incoming and receive, and so on and so forth, so on and so forth. So wow, time really flies. I really have 10 minutes left. I cannot believe this. Oh wait, yeah. 15 minutes left, my bad. So I'm gonna take it up. Oh wait, wow. Yeah, time really flies. So yeah, that's okay, cool. Now let me just show you guys my code, so that I don't waste you guys any more time. Close all. So this is my code, right? Freezer applet. Right. So unlike all the other things I was showing you guys, this has way more lines of code. 700 lines of code, but it runs, right? And the core components of it, oh yeah, and there's 2 things. There's Freezer SDK and Freezer applet, right? And okay, and this is going to be interesting. The Freezer applet is just the core logic, right? It doesn't have sim toolkit applet functionality. It doesn't have a user interface. It has 780 lines of code. The STK is the one that the user interfaces with, and it has 1,200 lines of code just for the displaying of the user information and stuff, because there's no strings, right? So I almost doubled the number of lines of code for this file just by giving it functionality to show a user, just because Javacard is so outdated of a technology, and it's C and Java having a baby. Javacard is the result, right? And cool. So where do we start here? So let me start this side. So for me, the most important thing is the menu, freezer, wallet, about. So then I have items as an array, which is wallet and about. And then for the wallet, if you select wallet, you will get the wallet title, wallet, then the rest of the menu items, which is send, receive, history, so on and so forth. And then I put that in an array as well. And then if you select send, I create a title for send. So then I create items for send, which is Satoshis or Bitcoin. So are you sending in Bitcoin or Satoshis? This is what your wallet should say, right? And then I add those to an array for later. And then a prompt, right? Prompt, if you're sending, how much you're sending. Enter an amount. Cool. An address. Enter an address you're sending to. So this is like a full wallet functionality. But then after all of that is done, oh, okay, cool. Then there are things on the Java card that I'm doing, like keys. I'm storing keys. I'm storing the key pair. This is the private key now. The public key, private key. But okay, I have them in the key pair, so I technically don't need them here. But I have them here anyway. And chart 256 helper, ripe MD helper, and the length of an uncompressed key, the length of a compressed key, somewhere here too. And then I instantiate them right at the start. So the first time you run the thing, I create a new private key. For now, this is testing. This is not how it should work. because I'm gonna make it generate with a little more randomness, right? For now, it just runs at the start, and cool. I set the curve, the CACP256K1 curve on the public key and the private key. So it gets set on the key pair as well, and then temp buffer. This guy's doing a lot of heavy lifting, right? So you will notice that the temp buffer is not just an array, but a transient array. Right? So this is quite important. So everything here that is not transient is persisted to the SIM card. So every time you open the SIM card applet again, you will find whatever previous data was there last time you ran it. So this is why the private key and the public key are stored, right? Because whatever value is here now, when I generate the key pair, will be on that SIM card forever until it's overwritten by something else, right? So why do we have a time buffer, and why do we make it transient? Shouldn't we just write to it and read to it? Well, since it's stored to the persisted storage, what you should know about persisted storage is that it has a limited amount of reads and writes. Right? So every read and write is eating into the lifespan of the chip. Right? I think 100,000 reads and writes. So as soon as you go over the lifespan of the chip is burnt out and the chip doesn't work anymore. So and that is the security mechanism I was talking about with regards to the private key on the SIM card. If you keep hashing to figure it out, you just burning it out, right? So, and once it's burnt out, it's done. There's nothing you can do to read data from it again, because all of the persisted storage has gone kaput, right? Cool. And then we do some message digest for chart 256 and ripe stuff. And who else and what else? Oh yeah, this is registering for the SMS event. There's 2 formats. There's 6 formats for the SMS event. You would need to read the doc for it. So there's binary SMS, which never shows up in your SMSs, right? So your telecom is sending your phone SMSs all the time. Those are binary SMSs, and those are the SMSs we'll be sending the phone when we want it to trigger an action, like show you a prompt to sign a Bitcoin transaction or whatever, or put a request for you to sign a Bitcoin transaction, or see your balance. So yeah, if you want to see your balance, we might send you a binary SMS and update the balance that is stored on the SIM card. Right? Cool. And then I'm gonna stop looking at the process SDK and look at the process applet. Right? So this was me for the past 2 weeks. Right? I was re-implementing stuff like what is this? 117. Oh, okay, no. Encode. No. Oh, SIGWIT. Yeah, so I'm currently re-implementing SIGWIT to run on this thing, but back into the code base, you can then go back to, let's say, the Machangura folder. Machangura, and then Freezer Javacard. Cool. This is a Freezer Javacard project. Oh, but since we're all here, let me show you something else. So this is a code base that runs Machangura, right? So all of these files, all of these folders effectively run Machangura. Components, db, clock.com, Javacard, webcard. What's the webcard? Whew. Yeah, and watts and rain and all of these different components play a certain role in the Machangura stuff. But for now, we are in the Freezer project, which is over here. And so when I make this open source, you're gonna find this folder called the Tysis dev. Tysis is the company who made the chip that I'm talking about, right? But their main things are closed source. This is their repo. Right? But when you buy their card, they give you all these other ones, right? And have you believing that all of this stuff is closed source? No, you can find all of this on the internet, but not easily. And they also include an EXP and what is this? Okay, but stuff, right? Cool. And these are things you would need to actually develop Javacard. Without this stuff, you do not develop Javacard. This one, sim.jar, is what has the sim toolkit logic. And yeah, a few things. I added my own things like JUnit and stuff, and jcard sim. So with jcard sim, I can then run and, let me see it runs. Oh my god, what did I do? Freezer applet. Okay, cool. Just want to run it for the one time. Oh, get poly. Well, this was something I wanted to test out, but I didn't have time to, so I'm just gonna comment it out. Cool, and then build again. Cool, build successful, and then I run build test. So then, yeah, this is effectively what I was doing. Right. So as you see, this is some logic for me to see if I've re-implemented a SegWit address correctly. So this is correct. This is the same as that, right? And this is the public key that's stored on the Java card. Right? I think when I run it, it should change. I'm not sure. I believe it should change. Yeah, it changes. It ends with 67F4, and then this is CCFDD, right? So it changes every time you run it, because every time you run it, it generates a new one. And then this is the compressed version of this public key, right? So this is what Bitcoin prefers. Bitcoin uses the compressed version of your public key. Did I have to re-implement this? I think so, but it's not too hard to do. And then you char 256, the compressed public key, and then you do the right message digest of the char 256 thingamajiggy, and then you can generate your SegWit address, right? And so this is where I am right now, right? So I just want to show this to you guys. This is the message digest, the SegWit address generated by the my Javacard logic, and then this is the SegWit address, the actual SegWit address. Oh no, yeah, this, the top one is the actual SegWit address, and this is the SegWit address generated by my project, and the checksums are different, right? But everything before the checksum is the same. I hope you guys can see that. Everything before the checksum is correct, and then the checksum is not the same, right? So I am doing the checksum calculation wrong because I had to re-implement the logic that does the thing. So here's me encoding bcash back 32, and I transform everything to lowercase, especially the human readable part. The human readable part in this case is BC. That's the human readable part, and then that means Bitcoin. Right? BC means Bitcoin, and then I create checksum. So I've made a function that creates checksum, and this function is wrong because this value is wrong. This value we have here is wrong. So I'm still in the process of figuring out why it produces a wrong output. And that is why I commented out some code there. Once we have this, we're good, we're happy, and we are good to go. So then all this logic is basically re-implementing all the Java logic that I'm finding in the world. Create checksum. I re-implemented something to expand the human readable part into a binary format. This polymorph thing, I think this is where the calculation is wrong, and then I'll have to figure out what's wrong about it. And yeah, so effectively all I'm doing, oh, and I need to show you guys this. All I'm doing, oh yeah, okay, so this is me and ChatGPT. When I have a crazy idea, I just go to ChatGPT and, just see what ChatGPT says. So I say camouflage curtain made out of palm plants, and then it for palm trees, right? But then hand palms, please, right? Yeah, so yeah, you might see this somewhere one day, right? So yeah. And oh yeah, so this is me, my relationship with ChatGPT, right? So ChatGPT is very stupid, guys. Never use this to learn and do anything in your life. This is a toy, right? But that being said, it has helped this project quite a lot, right? When I started out, this is what I used to do: Java card code for Bitcoin. Alright, and then it would, give me Javacard code that can be used to sign a Bitcoin transaction, and then it would give me stuff, and then you would think I could just copy and paste the stuff and it works, right? No. Right? So they are doing a lot of stuff wrong because there's no ACDCA class in Javacard. There's a key pair class, but a lot of the things they mention here do not work and do not exist. Right, and in Javacard, there's this thing I was doing, which is the message digest stuff, right? Because you have to manually do it. Where is it? Chart 256, right? Because it's not a primitive. You don't know what type of chip a person has, so you have to do it step by step. Do chart 256 first, do write MD digest after. But then I learned that, okay, you can force your Java card helper to take you one step at a time, but that means you need to know the steps you're taking, right? So and you may have seen some of these. I gave a talk where I use Rorschach style images, right? So this was me telling the AI to generate some of these things in a certain Rorschach style, and these were those images. And then let me see, what's this taproot? Okay, but yeah, then I got back to the Java card project. This is part of it, like Java RMI, Java Remote Some Message Interface. I don't know about it, but I just said that word. If you're researching, I believe at some point it's going to be important. Yeah, I don't know for now, right? And then I asked it to do research for me and find the projects that I was showing you, like those Java projects, Java card projects I was showing you. Where is it? This one, right? And then it gave me a good list. But then you have to really take it one step at a time and tell it where it's wrong as well. Right? So now at least I can come back later and say the polymod function, this one, is wrong. Right? So what is wrong with it? Right? So this is what I believe. The normal polymorph function in other code bases, and this is also what I do, Bitcoin J. Yeah, SegWit address. Bitcoin J implements a SegWit address, and it also implements a back32 thing. Right? So I look at them and I'm like, oh, this is what these guys did. I think this is a project I got the polymod stuff from. Yeah. Right? And then they have ints, so they don't have to worry. Right? And then I go to who's this guy? ChatGPT, and I say, ChatGPT, can you implement this function for Javacard without using ints? Right? That is the wrong prompt. ChatGPT will get it wrong. So the reason why it's wrong is sometimes you can use short. Right? Short is just as good as 2 bytes. Right? So in some of these cases, you cannot use an int, but you can use a short, and you can use this thing for a short. Right? So the thing I think I got wrong here is I didn't use a short where I could have used a short. So you see my C is a byte array, and then I only shift the first byte or the last byte or something. Oh yeah, and that is the other thing. So am I shifting the first byte or the last byte? Because bytes have little endian and big endian. In data, in computer science, you can either start with the most significant byte first or the least significant byte first. And I don't know why computer scientists decided to do the stupid thing. They should have said there's one way to do it and stuck with it. But yeah, that may also be a reason why this is wrong. And yeah, all the other stuff that I was doing with ChatGPT. So I also realized that there's other languages, not just Java. So I could ask ChatGPT to convert from Python to Java. So I take a Python script and turn it into Java, and then cool, from here I can use this, but I cannot because here's ChatGPT using an int, right? And so yeah, then you are forced to figure out how to do what you need to do. And they're calling me because I'm over time. Hello, Herman. What you doing? No, you're not. I'm doing a workshop, and I think people are happy to hear from you. Oh, okay, but I'm coming. I'm almost done. I'm coming to you now. So, okay, cool. Yeah, and that's about it. Any questions?
So for the any non-coders here,
Mm-hmm.
like me, I'm not really a coder.
Yeah.
If you could just tell us what your goal is in the future.
Uh-huh.
To, what is it you want to roll out
Mm-hmm.
into the Bitcoin ecosystem to make people's access easier?
Okay. Yeah. So this is the stuff. So I basically plug this into my laptop, right? Um, oh yeah. So I've built the project. I converted into CSR or a cap file, and then I put the cap file. Oh yeah. So you see, it's orange. But if it, yeah, Javacard. Oh, oh yeah, it compiles into Java and then Javacard. Oh yeah, so let me show you that part about it. Where is the freezer thing? So, oh yeah, and okay, when this becomes available, there's a build.xml, right? So for you to build it into Javacard, there's a task we define called Javacard. Okay, we define a Javacard task because of this ant Javacard thing, right? And then it understands what you're doing, and then you tell it what to produce, and you're producing a cap file, right? And let me see, where's that cap file? Build, here's the build, cap file, freezer.cap. So, yes. Yeah. So the version I'm using, oh yeah, so there's different versions of JavaCard, eh? The versions I'm using is 3.07. Yeah. So yeah. So the rest are there if I want to use them, but for now I'm just using 3.04, and then it produces a cap file. Once you have this cap file, you can do whatever you want with it. No, no, not yet. Yeah. So for you to copy it over to a SIM card, you do some magic because the SIM card has a private key, right? So the magic converts this into something that the private key has already signed. Yeah, so if you don't know the private key for your SIM card, you cannot do this. Yes, but then you can buy a blank SIM card and they just set whatever private key you want on that SIM card, but that SIM card will not have a network connection. And that is why for this project we are using SIM overlay. So with SIM overlay, this chip is as thin as this plastic film, right? And yeah, that's about it. This is from Tysis, so you can order a dev kit from them if you wanna play around with it. But I think I'm gonna talk with them to get a few dev kits in South Africa, and so that you don't have to pay customs. Yeah, and then for where this is going is effectively, okay, Machangura will have a brother or sister who is a self-custodial service, and we're gonna shop it with the telecoms to say, yo, if you're a telecom and you want to make a splash, but you don't want the counterparty risk of custodying your users' Bitcoin, over the air today, we can give you something that will turn every SIM card into a Bitcoin wallet. Oh, yeah, and yeah, that's pretty much it. So then this cap file goes to this telecom, and then the telecom is able to give a Bitcoin wallet to all their customers. And that is also the emphasis on not doing too much. Right. So there's so much you could do with this stuff, but if we make it work, just
If you know what you're doing like you do,
I don't really know what I'm doing, right? Look at this chat history right here. I don't really know what I'm doing, right? So, yeah, and yeah, basically. Hmm. No, I'm not. The telecom can. Yes. Yes. Yeah, I'm deploying this manually. Mhm. And yeah, but the beauty with this is that the telecom will not have access to this. So even when it's on my phone, it's its own thing.
And on the phone, so is it just for feature phones, or on a phone do you need like an app to actually
No,
access the?
it works on any phone, right? The issue is that these smartphones, the SIM tray is too thin, right? So whenever I try to put it here, it scrapes the plastic thing.
A few microns thick. Like
Yeah,
that.
it's quite thick, this thing, but yeah, maybe pass it around. Right?
Yeah.
And but yeah, whenever I try to put it in this, the tray is just too small, right? And it moves the thing out of where it should be, and then I might have trouble pulling it out. So I wouldn't advise putting it in a smartphone unless you have those smartphones that can put a SIM card at the back.
But so the moment you plug it in, it just pops up the.
Yeah. As a SIM toolkit applet. Right. There's a phone here that has it. Let me see. Oh yeah. But while it's still off, let me just show you. Oh, can we get the lights again? Oh, this guy put the SIM card wrong way. Wow. Oh, no, I cannot get it out. Can you believe this? Baby, baby, you. Oh yeah, cool. So this is the SIM card. Pass it around. Alright, so that chip there ended up on that SIM card. No.
So is it gonna be 12 words or 24 or?
12 what?
Like words or?
Oh yes. I won't be doing that. Right. So what I'll do, you see how Moon does it with the recovery code. Yeah. So the Moon way of doing it is the best way of doing it because we are in a continent where English is not the first language, right? But a person can see these words, right? And remind me to sweep this wallet and never use it again because it's on camera right now. Right? And so the thing though, about these was that works so well. If you're not an English speaker and the BIP 39 words are not there for your language, it's okay because it's gibberish for you too, right? And product codes. There's a product code I think underneath my laptop.
That's a great point to
Yeah.
remember.
Uh-huh.
When you working with adoption.
Exactly. Right, so do they not put product codes on laptops anymore? Anyway, yeah, so the thing about this, thank you very much, is that this is version 2 of Moon's thing, right? So I want them to do version 3 with a checksum, right? Because with this version, they are the ones that check that you actually have a valid recovery code. So if they don't have a corresponding public key with the recovery code, or your phone generates a public key and then sends it to Moon, and that's how they authenticate you, right? But we want it to work decentralized, so it needs a checksum. So we're gonna have like the last 5 words be the checksum or something like that, and yeah, that over BIP39. Right. The first version will not have recovery, so if you lose the funds, they're gone. Yeah. But when we do it, we're gonna do it like that.
And then you would back up the encrypted, just so you're backing up the encrypted C basically, well the private.
No, you backing up the recovery code.
Oh.
Yeah.
So that is the C just in a different format.
Yes,
Okay.
yes.
How big is the SIM card? Like how big is this program?
I don't know, man. I don't know. Actually, let me check. The cap file is,
Okay, like much bigger.
I think less than. Yeah, I think this is 50K, 50 kilobytes, right? But I think when it gets converted to the format that ends up on the phone, it's even lesser. Yeah, even smaller. But I don't have the Windows machine. Yeah, because I can only write it to the Javacard with Windows. And yeah, so 51K. So yeah.
That would be like a expensive real estate for telecoms to put it on there if the SIM card is too small.
Oh yes. So that's why at the end of it all, it will be way smaller. Right? And yeah, this is the company I was talking about, Tysis Technology. And yeah, so you can make a custom SIM card with them, and financial and banking stuff like this. And yeah, it's just weird. Oh, there's other projects like Simple ID, right? This guy used the SIM as well, uh, because he's like, some feature phones have a screen, right? A color screen, right? So why can't you show a QR code on this color screen? And this is effectively what he did, right? And I'm like, what the? Oh, these people are cracked, right? And so he goes to his SIM toolkit applet, right? And Simple ID, and then it shows my NIN and QR code on a feature phone. Right? Yeah. So I'm like, okay, there's really a lot that's happening in this space, but his project requires a lot more tinkering with the actual device for it to work, right? But theoretically, it's possible if you know what's on the feature phone, right? So the concerning thing about this project, right, is this work was supported in whole or in part by the Bill and Melinda Gates Foundation, right? So it's 13,000. So they've been funding 13,000 other projects. Oh, okay, but this guy's the one who issued the invoice. Okay, so it's not that concerning. But yeah, so Bill and Melinda Gates are kind of...
That can be used in the fiat system as well.
Yes, and
That's
this is why they're doing
that's
it.
why
Yeah, right. And yeah, so CBDCs and stuff like that.
That's why what you did is important, because you rightfully there.
Yeah, but they are years ahead. Look at when you get the time, Google Bill Melinda Gates Foundation M-Pesa, or foundation, or mobile money actually. Right? They have been talking about this stuff for years, and I think they are impressed at the pace that mobile money blew up in Kenya. Right? And of course they want to develop a system that they are in control of. So once they figure out how to do it in a way that it works on anything, and censorship resistant as well, pretty much they will. And then I think they have enough money to fund it. Right? So there's a lot of good research to also read on the topic from them, which is, it is what it is. But yeah.
Yeah.
Question? Okay. Yeah. Cool. Thank you very much, guys. Yeah.